the turbine rotor of a ship has a mass of 2.2 tons. So here we are having a ship, and in this ship there is a turbine rotor, and this rotor will be having a mass of 200 2200 kilogram, and it rotates with 1800 rpm clockwise when viewed from the aft. That is, when viewed from the rear end, it is rotating with this much rpm, and it is in the clockwise direction, that is in this direction. So it's in the clockwise direction. Now its radius of gyration k 0.32 meter, it's given, and we are asked to find the couple and effect. Now when the ship rotates, when the turbine rotates, naturally it's rotating in the clockwise direction when we are looking from the rear end or the aft. That means if we are representing the angular velocity will be towards the turbine, so it will be somewhat like this, and its mass is given, and its radius of gyration is given. So if we are multiplying it with the mk square, if we are finding mk square, we will get I is moment of inertia. Similarly, since rpm is given, we are able to find omega of the turbine, that is 2 pi n by 60, omega of the turbine. So omega of the turbine is equal to 2 pi into 1800 divided by 60. So we will get the this one, we will get somewhat like 30, so 60 pi, so we will get omega. Now we are asked to find the couple and effect. So first one, the general formula for the couple is I omega p. Why I have said the general formula is, there are three cases. First one, ship turns right, second one, ship pitches, and third one, ship rolls. In each case this omega p will be different, and that we will find how to get that omega p. So first, in the first case, initially it is this rotor is rotating in the clockwise direction, so we have the direction of this omega towards this propeller or towards the turbine. Then ship turns left or right, ship turns right, it is given in the question, ship turns right. So suppose if ship is turning right, first ship was like this and omega was like this, now ship is turning right, then omega will be omega will to turn right, so that the new omega we can represent somewhat like this. So the changing omega, so OA is the initial, OB is the final, so change in omega is represented by this AB. So a reaction force, that is A dash B dash, will be formed, and because of that there will be a gyroscopic effect. And if we are keeping our right hand like this, we can see that the effect is like this. That means because of this gyroscopic effect, it will act like somewhat like this. This nose or this bow end will go down and rear end will rise. So that is the first case. So here what we have to remember is, first one, we are looking from the aft end or stern end, and this one is this one, and it is a propeller is rotating clockwise, and if ship turns right, then what happens? Bow will dip. So this is the first table that we want to remember. Now suppose say that we are looking from the aft end, and the propeller is rotating in the clockwise direction, and if ship is turning left, then exactly opposite will happen, bow will rise. So that's how, by using this table, we are able to get all the effect. If any one of this column changes, then exactly opposite will happen. Now we want to find the gyroscopic effect, couple. So couple is I omega p. So here, when it is turning or when steering happens for the ship, then omega p is equal to v by r, where v is the velocity of the ship in meter per second, and it is given 25 km per hour. Omega is velocity is given. So 25 into 5 by 18, we will get velocity in meter per second divided by radius. Ship turns at a radius of 250. So we have obtained omega p. Now omega is already known. It is 60 pi, 2 pi n by 60. So I is mk square. So if we are substituting those I, omega and omega p, we will get this gyroscopic couple for the first effect. And for the second effect, so second effect means ship pitches. Pitches means this type of motion is called pitching. So ship pitches with angular velocity. So angular velocity will be given like some 0.8. In this question, ship pitches with angular velocity 0.8, and it is given that bow is rising. Bow is rising. So what happens is ship pitches with the angular velocity 0.8 and bow is rising. So there what happens is this couple will be having the same formula. C for the second question, C is I omega p, and I is for the rotor 2 pi n by 16. Similar to earlier case, it is 2 pi into 1800 by 60 pi. It is similar, but the thing is I is also mk square. There is no change, but omega p will be different, and it is directly given in the question. Ship pitches with angular velocity 0.8. So directly we can substitute that omega p. Here we do not go for the omega p that is equal to v by r. V by r is substituted only when ship is steering or it is turning left or right. Here omega p is given directly. So by that thing we can find this couple or gyroscopic couple. Then effect means here it is given that first ship is this one is rotating clockwise direction. So we have angular velocity towards the propeller or towards the turbine. Then it is rising. Rising means ship is rising somewhat like this. That means angular velocity to its direction to rises. So it will be somewhat like this. Then this is the change in angular velocity. So its reaction will be like this. So if we are putting our right hand, then reaction is acting in this direction. That means it is pushing this rear end to the left. That means our ship, so reaction will be acting somewhat like this. So because of that, our ship turns right. So ship turns right. So here too we will introduce a table which says we are looking from the stern end or aft end, and propeller is rotating clockwise, and if bow is rising, then ship will turn right. And this is actually exactly opposite to that of the first case. So here we are looking from the stern side, and propeller is or turbine is rotating clockwise, and if bow is rising, ship will turn right, and if bow is lowering, or say that this stern end is rising, then ship will turn left. So by this single table we are able to solve the effect. Now ship rolls at angular velocity point. Third case. In third case it is rolling, and actually because of rolling there is no gyroscopic effect. Means there is no tilting, turning, etc. But there will be a couple acting. So the same formula again, I omega p. So I is moment of inertia, omega is 2 pi n by 60. Omega p is directly given in the question. Angular velocity ship rolls with the angular velocity point, and that will be substituted. We will get the gyroscopic couple. But we will write that there will not be any effect, and there is not any effect because this rolling angle. Rolling means this is the rolling. So that axis and the axis of the propeller are same, and because of that there will not be any effect. So this is how we solve this problem.